Good morning, ladies and welcome back. We're going to talk about a lesson called Graphs of Exponential Functions. And of course, we're going to talk about what this one looks like. Y equals 2 to the x. This is an exponential graph. Some students would argue, why isn't this one y equals x squared? Notice the unknown for this one is the base. A lot of you already know that this one, y equals x squared, that's the parabola. It's the funny looking view that looks like this, right? So a lot of you realize that. So when it's this, the unknown is the exponent. That's why it's called exponential. So we can do definitely a table of values. And how we do this, I'm going to go from -2, -1, 0, 1, 2, and 3. I do encourage you to compare the table of values of y equals x squared to what we're doing right now. But because we're out of time, we're running out. When I do the math of this, -2, plug that in, that's 2 to the -2. A lot of you already know that 2 to the -2 is 1/4, or 0.25. Rinse and repeat, 2 to the -1, that's 1/2. 2 to the 0 is not 0, it's actually 1. Notice, a lot of students actually realize when I'm teaching you guys critical points, this is clearly a nice critical point. And I'll get to this in a moment. It's the y-intercept. 2 to the 1, well that's, oops, 2. 2 to the 2, that's 4. And that's why there's a reason why I decided to go here. Because if you only saw 0, 1, 1, 2, 2, 4, 3, if you only saw these 3, or even these 2 only, it would almost look like the parabola. But when 2 is raised to the 3, that's 8. I apologize, I'm only going to be sketching. And if you were to graph these out, -2, -1, 0, 1, 2, and 3, you're going to get something that looks like this. Okay. So this point is 0, 1. And so all of these functions clearly have a y-intercept. It's a y-intercept. Also, some of you realize what I'm going to be drawing in a moment in yellow. A lot of you realize, Mr. Chan, what happens if we have maybe x is -10 or x is -1,000? Well, it'll be maybe 1/1,000 or something like that. So a lot of you realize this yellow line that I'm drawing, if you're at home, you know, you can see it. Anybody from the class actually recognize what that is? Tanush? Asymptote. It is an asymptote. More importantly, it's the horizontal asymptote, but he is correct. And it actually has a value of y equals 0. What does that really mean? For y equals 2 to the x, it will never cross the x-axis. Remember, we're going to have functions for this. Anybody from the class who would like to describe what they're seeing, though, if you look from left to right, how would you describe it? Starts with the letter G. Anybody? How do you describe this? Or not, you can use the letter D as well. It doesn't actually use a particular pattern. Don't look at the x values, look at these values. 1, 2, 4, 8. Without even doing the calculation, what will be the next number, even though a lot of you played this game on the cell phone? Maybe not. I'm dating myself, I don't know. Mr. Chen, what is that? This is just a number. Oh, I didn't.
It's like doubling?
It's doubling. This is actually a doubling graph. More specifically, although this one actually is doubling. But the G word that I was looking for, this is called the growth rate. Exponential growth. Some of you have actually seen it already from maybe SAP or some anthropology course, or you're taking some social science class. A lot of you realize, no offense, in 2020 we're dealing with the COVID pandemic, and it's related to the concepts that we're talking about. Okay, and not this one per se, but the idea of the growth of the virus. Let's just pause here for a second. Any questions about this? The second graph that we're going to do is almost identical. And I'm going to change the base to y equals half to the x. Okay? Now this time, watch what I'm going to do. I'm going to choose the x values of -3, -2, -1, 0, 1, 2. So, any volunteer want to try to tell me? What is 1/2 to the -3? Now, if you need to use a calculator, be my guest, it's okay. But some students actually know what I'm doing. And that's okay too, because I tend to teach us well. Tanash, it is 8. It is 8. 1/2 to the -2? It is 4. And slowly started realizing it's going to go like this. Oopsie. So, I am over. Let's just roll this over. Sorry, Owen. So, what is this graph going to look like? Oh, I can't do that. What is it going to look like? So again, clearly, 0, 1 is a nice point. And this is our y value. And again, I apologize. I'm just going to sketch. I'm glad I'm going to make it. Ah! Garbage. Let's try that again. Much better. It might be better at home or using some software. I'm just sketching really quickly so we get the idea across. 1, 0, 1. Any volunteer person want to describe this one? This one's a little harder than that. Hi!
Is it a habit?
It is a habit, nice. Y equals y equals 1/2 to the x is a halving. Now, I don't like using halving because it sounds like I'm saying having rather than halving. So to get rid of that, I use an old famous Valve video game name. None of you know what I'm talking about. Half-Life. It's not out yet. Half-Life 3, not out. No, none of you. None of you. We have a student here that says, Mr. Chen, I don't know what K-pop is. That's okay. This is Half-Life. So this is growth. This one actually is a particular, and it's related to this word. Some of you might have already taken in chemistry or not. Anyone know what this is called? This is actually a particular word. Not degrowth. That's not right. You want to know what I'm talking about? Half-life. Anyone have heard of this? Have you guys heard of this term, half-life? Right.
Yeah.
What were you gonna say?
I'm just saying I heard it in chemistry.
Chemistry, yeah. Do you remember?
Yeah.
He's not answering this, folks, ladies and gentlemen. Alright, so this graph is also known as a decay. So that's what this is called, decay. And why is it called half-life and decay? Is because everything actually decays radioactively. Everything. Like the walls around us, our bones and everything. That's how they actually do, you know, carbon dating of the isotope for dinosaurs, carbon-13. Stuff like that. So half-life, how much it actually decays down to. This one also has a horizontal asymptote, which I think a lot of you realize. Looks like I should put a flash, whatever. So notice we've done equation, table of values, and the graph, right? And you kind of needed to recognize it. These two are famous. The reason why some students would ask, why did I not change this to 3 or 4 or 7.7? Or why did I choose like 1/2? Why did I use 1/3 or 1/4? These two tend to be the famous ones for our exponential growth. Because believe it or not, some of you realize they're actually kind of related to each other. Okay, anyone to make that aha moment before I get to the transformation? Hi, Christina.
Are they flipped by the middle in the 0?
They're flipped. We can use some math terms that I taught you. I'll give you a hint. So,
Vertical reflection?
not vertical. Okay, hold on. So I'm just gonna redraw them. One looks like this, and the other one looks like this. Now that we put them together. Emma?
Reflection across the wall.
It's a reflection across the y-axis, and in fact, let me realize you can rewrite this, right? this fraction. Can I get a volunteer to rewrite 1/2 as an exponential? Oh, I know 1/2 to the 1 is correct, but that's not the answer I'm looking for. It's the idea of what Emma said. Did anyone try?
X to the power of -1.
Sorry?
X to the -1.
What's the negative? What's the base?
2.
2, nice. 2 to the -1. So you're slowly kind of connecting that this equation, y equals half to x, this is also the same thing as y equals 2 to the -x. Right? So to speed this up, ladies and gentlemen, really, really quickly, down here, as a recap of the function transformation that you've been taught, hopefully you've seen through all the packages. We try to give you this summary how it looks like in terms of sine, cosine, or tangent, or even the other transformation of the base functions. This is clearly this idea of what we talked about, the reflection across the y-axis. It's clearly a k value. And so what is the general notation for this? So for us in exponential functions, it looks like this. I'll put it up here. Y is equal to a, they might use a b for base, and then k x minus p plus q, where the k and the p are there. Now they might not use the b, they might use the letter, let's see it. Yeah, they did use b, but they use the lowercase b. So that's what we're talking about. So some already know what we're going to do in the future. Okay, let's just pause here for a second. Any questions what you're seeing with these two graphs? So if you look at the PowerPoints, you can follow along with the exercise, and I'll see you in the synchro class.